Hi everyone! In this lecture video, we are going to discuss about the logarithmic function and its application. So for our objectives, at the end of the video, the learners are expected to first, represent a logarithmic function and its table of values, graph, and equation. Number two, find the domain and range of a logarithmic function. And third, determine the intercepts, zeros, and asymptotes of a logarithmic functions. And lastly, solve problems involving logarithmic functions. So let's go back to the definition of logarithmic functions. For all positive real numbers x and b, x greater than 0, b greater than 0, and b should not be equal to 1, the inverse of the exponential function y is equal to b raised to x is the logarithmic function y is equal to the logarithm of x with the base b, or f of x is equal to the logarithm of x with base b. Now recall that we can read it as y equals the logarithm of x base 2, or y equals the logarithm base 2 of x. Now, let's have a challenge. Okay, so this is a problem about population growth. So the population of the Philippines can be modeled by the function p of x is equal to 20 million times e raised to 0.0251x, wherein x is the number of years since 1955. So since we have the condition here that the x is the number of years since 1955, we let x is equal to 0 at 1955. So assuming that this model is accurate, in what year will be the population reach 200 million? Now, to answer this kind of problems, okay, let us learn first how to do the table of values and sketching the graph of a logarithmic function. Now, let's have an activity. So let's construct the table of values for the following function. So sketch the graph of each and compare each to its corresponding exponential functions, and also compare the functions from one another. So we are going to compare the graphs of these two. So we have number one, y is equal to the logarithm of x with base 2, and number two, y is equal to the logarithm of x with a base 1/2. Now, let's try first y is equal to the logarithm of x with base 2. So here's the table of values. So we have the x and y. If x is 1/8, y is -3. If x is 1/4, y is -2. If x is 1/2, y is -1. If x is 1, y is 0. X is 2, y is 1. If x is 4, y is 2. And if x is 8, y is 3. Now, for assigning values, we can assign different values for x aside from these values. It depends on you so that you can sketch the graph of the logarithmic function. Now, the graph looks like this one. As you can see, here's now the graph of f of x is equal to the logarithm of x with base 2. Now, if we're going to describe this one, the graph is increasing. Okay, it is increasing, and then the graph is also asymptotic to x is equal to 0, or the y-axis. Okay, so to identify the domain of this logarithmic function is x is equal to 0. So as you can see, the graph can only be found on the first and the fourth quadrant of the Cartesian plane. Okay, so as you can see, the values that can be found, or the x values that can be found on the first and fourth quadrant, are only positive numbers. For the range, so the range of this function will be all real numbers. The x-intercept is 1, 0. Why is it 1, 0? Because the graph intercepts the x-axis at exactly 1 point. So that is exactly 1, 0. So here's the point where it intercepts the x-axis at exactly 1 point. Next, the y-intercept does not exist because the graph is asymptotic to y-axis. And also, uh, the vertical asymptote, so this describes why it is asymptotic to y, since the vertical asymptote will be at x is equal to 0. So when we say x is equal to 0, basically that is the y-axis. And then the horizontal asymptote does not exist. So obviously in our graph, we do not have the horizontal asymptote. Okay? And then to describe the graph in general, the graph is increasing. So let's try to observe. Okay, so we're done describing the graph of y is equal to the logarithm of x with base 2. So let's try to compare it to the exponential function y is equal to 2 raised to x. So comparing y is equal to the logarithm of x with base 2 and y is equal to 2 raised to x in terms of their graphs, this is how it looks like. So as you can see, they are symmetrical with respect to y is equal to x. And the red graph, okay, the red graph here describes the graph of g of x is equal to 2x. And then the black graph describes the graph of f of x is equal to the logarithm of x with base 2. So as you can see, they are symmetric with respect to y is equal to x, and then they have the same structure, but they are in different positions. So as you can see, they are just inverses of each other. Okay, so to describe them in general, the graphs will be symmetric at y is equal to x since they are inverses of each other. So we can now conclude that the logarithmic function and its exponential function will just be the inverses of each other. Okay, so let's try to graph y is equal to the logarithm of x with base 1/2. So here's the table of values. So we use the same x values. So we have 1/8. So if x is 1/8, y is 3. If x is 1/4, y is 2. If x is 1/2, y is 1. If x is 1, y is 0. If x is 2, y is negative 1. If x is 4, y is negative 2. And then if x is 8, y is negative 3. Now, if we're going to plot it in the Cartesian plane, the graph looks like this one. Okay, so here's the sketch of the graph. So here's the illustration of f of x is equal to the logarithm of x with base 1/2. So as you can see, the graph also touches the x-axis at exactly 1 point, which is 1, 0. And then the graph is decreasing. The graph is decreasing and also asymptotic to x is equal to 0 or the y-axis. Okay, so the domain of the logarithmic function is x greater than 0 or positive, all positive real numbers. Okay, positive numbers or positive real numbers. Next, range all real numbers. Okay, the range of this graph or this logarithmic function are all real numbers. The x-intercept is obviously 1, 0 because it intercepts the x-axis at exactly 1 point, which is 1, 0, and then the y-intercept does not exist. Okay, so the same with the first one, this graph is asymptotic to x is equal to 0 or the y-axis, which describes the vertical asymptote, which is x is equal to 0. And obviously, the horizontal asymptote does not exist. Okay, so this to describe the graph in general, the graph is decreasing. So to compare the graphs of these two, y is equal to the logarithm of x with base 2 and y is equal to the logarithm of x with base 1 half. So this is how it looks like. So they look the same. Okay, so they look the same, but they differ with respect to their behavior because the graph of the logarithm f of x is equal to the logarithm of x with base 2 is increasing, and the other one is the graph of f of x is equal to the logarithm of x with base 1 half is decreasing. But the other description or the words that can describe their graphs are the same because they both of them has x-intercept of 1 and both of them also asymptotic is asymptotic to y axis or x is equal to 0. Okay, so from this example, we can now have the properties, or it can, it can already explain the properties of logarithmic functions of the form f of x is equal to the logarithm of x with base b. Okay, so for the first property, the domain is the set of all positive real numbers, or we can write it this way, that the x is an element of real number such that x is greater than 0. So if the logarithmic function is in this form, okay, f of x is equal to the logarithm of x with base p, the domain is always the set of all positive real numbers. Okay, so we're done with number one, property number one. Property number two says that the range is the set of all real numbers. So if the logarithmic function is in the form f of x is equal to the logarithm of x with base b, the range is the set of all real numbers. Property number three, it is one-to-one function satisfying the horizontal line test. So obviously, if we do the horizontal line test, it will only touch the graph once. Number four, the x-intercept is 1. So if you can still remember, both of the graphs of this form intercepts the x-axis at exactly 1 point, which is 1, 0. Property number 5, there is no y-intercept since both of the graphs are asymptotic to y-axis or x is equal to 0, and which explains the property number 6, which is the vertical asymptote is the line x is equal to 0 or the y is equal to or the y-axis. And number 7, there is no horizontal asymptote. So by the look or the illustration of the graph, so obviously there is no horizontal asymptote. But what if the graph of f of x has constants? So we have a, x, c, and d. Okay? So if the graph of f of x is equal to a times the logarithm of x minus c with a base b plus d, the properties are as follows. So the value of b, either b is greater than 1 or b is greater than 0 but less than 1, it determines whether the graph is increasing or decreasing. So the value of the base describes if the graphs will be increasing or decreasing. Number 2, the value of A determines the stretch or shrinking of the graph. So further, if A is negative, there is a reflection of the graph about the x-axis. So the A here, the constant before the logarithm, it will describe the stretch, okay, if it will be thinner or wider graph. Okay, and number three, based on f of x is equal to a times the logarithm of x with base b, the vertical shift is d units up if d is greater than 0, or d units down if d is less than 0. And the horizontal shift is c units to the right if c is greater than 0, or c units to the left if c is less than 0. Now, basically, it only just describes if or describes the behavior of the graph. So the d here, the one on the last part of the function plus t, it will describe if the behavior of the graph will move upwards or downwards. So it will move upwards if it is positive, downwards if it is negative. And then the C here, the C value here, will describe if the graph will move how many units to the right or how many units to the left. Okay, so to the left, if it is negative from the definition, so C is less than 0, to the right if it is positive. Okay, so let's try. So let's try to apply the properties and the concepts. So we have here an example. So the instruction here, we are going to construct a table of values and sketch the graph of the following functions. So we have three. We have f of x is equal to 2 times the logarithm of x with base 2. Number 2, f of x is equal to the logarithm of x with base 3 minus 1. And the number 3, f of x is equal to the logarithm of x minus 4 with base 2/5 plus 2. Okay, so here's the graph. So assuming that we're able to do the listing of table of values. So here's now the graph. So we are going to observe. So here's the graph of f of x is equal to 2 times the logarithm of x with base 2. So that is the look or the illustration. So it also intercepts the x-axis at exactly 1 point. So that is 1. It is also asymptotic to the y-axis, or x is equal to 0, and the graph is increasing. Okay, but let's try to compare it without the constant number 2. Okay, so if we are going to illustrate the graph of g of x is equal to the logarithm of x with base 2 without the constant 2, um it only it only doubles. Okay, so it only doubles the logarithm of x with base 2 times 2. Okay, so next, for the next one, we have f of x is equal to the logarithm of x with the base 3 minus 1. So if we're going to graph that, we have this one. Okay, so it intercepts the x-axis at 3, and then the y, the graph is asymptotic to 1. So it only shifted 1 unit down since we have the constant minus 1, or it serves as the d. Okay, so again, by definition a while ago, the d describes if how many units the graph will move upwards or downwards. For the C value, it will only describe if the graph will move how many units to the right and to the left or to the left. Okay, so next, let us proceed. So we have f of x is equal to the logarithm of x minus 4 with the base to fifth plus 2. Now, in this case, here's the graph. So we have f of x is equal to the logarithm shifted 2 units up and 4 units to the right. Okay, so going back to our challenge, the population growth. Okay, so the population of the Philippines can be modeled by the function p of x is equal to 20 million times e raised to 0.0251x, where x is the number of years since 1955. So we let the condition x is equal to 0 at 1955. So assuming that this model is accurate, in what year will be the population reach 200 million? So you can now answer this one using the table of values and sketching the graph. So you must get the answer of x is equal to 91. So good job, everyone. So going back to our objectives at the end of the video, the learners are expected to first represent logarithmic function through its table of values, graph, and equation. Number two, find the domain and range of a logarithmic function. Three, determine the intercepts, zeros, and asymptotes of a logarithmic functions. And lastly, we're able to solve problems involving logarithmic functions. Thank you so much.